So hello, this is our remote target detection and object identification group 2 for Senior Design 2. This project consists of me, Michele, Valerie, and Jose, and we're going to be giving you the updates of what we've done so far in our project. So I'll be going first. I developed the first RCS code um, for the detection for our project. So what I did was initially find the necessary libraries that we need and the packages that we need um, uh, to create this version of the software for us. And we needed to initialize the Pluto and generate RCS values, even if they were incorrect. My purpose of it was just to get a starting point, get the ball rolling. And then I also did some of the reading for the textbook that you gave us for chapters 2, 3, and 4. And then I also did the editing for our project demonstration video. And I also did the narration in that video, and I also made final changes to our abstract.
Okay, and I'll be going next. Uh, Over the past few weeks, we've been spending a lot of time on the theory part of the project because we want to end the software side because we wanted to get it set up so this way all team members will be able to collect data. So this way we can collect data simultaneously and we won't have we'll get as much data as possible without having issues of one person having to collect data while others, are stuck, not able to do other work. In the past few weeks, I developed a second version of the RCS code after looking through the textbook that was recommended. This code uses the monostatic formula for finding the RCS values. I chose that one to try to pick something that would be as general as possible, and it seemed like it was the most versatile. The book gave a lot of formulas for ideal RCS of specific objects where their values are known in particular. And so
Daniel, I don't see the screen. You move it. Yeah.
I don't know why it keeps moving. I'm not touching. Go ahead.
And so I tried to, so after learning that, we wanted to calculate ideal values. But for the code, we need something general. Otherwise, we're not going to be able to identify the object. It's pointless if we already know what the object shape and size are going to be. For integrating the Pluto on Windows, there was a little bit of going back and forth when we got it to work for some of our teammates who have Mac, and then we had to get back to Windows, and I helped with that process of getting through it. And then next slide. And then I also contributed to writing some of the report and doing some of the editing and formatting, did some of the narrating for the video, and helped to storyboard the video as well.
I'm Valerie Lastra, and whoops. I did for the progress report, I created like the rough draft of the project's progress. So like I pretty much did an outline of like what we completed, what we accomplished, and like just wrote it down like in a way that's like a paragraph format. And then my other group members created like the final created the final draft. And then I also created the abstract, and then also for video narration, I did just mostly the attention grabber to introduce the video. And for the video storyboard, I'm the one who came up with the skit for like how would the video play out and the organization of that. As for testing environment was what I did mostly for the implementation of to find the RCS values, because I realized that it is important in order to get closer to the ideal values. And we used like the table upstairs and pretty much came up with a setup that wouldn't interfere with just having it angled at a perfect, so it's not angled pretty much. As for the RCS theoretical work, I read the manual, and what I read in the manual that you provided for us, or the textbook, was like the difference between monostatic and biostatic in RCS, even though we're gonna mostly work with monostatic. And the different equations required for RCS, like for shapes and sizes, and then also radar dynamic cross-section and the difference between glint and scintillation. And as for the Windows integration for the Pluto, we incorporated into my laptop. I was able to program it into my laptop. I was having issues because we initially started with my laptop, and we finally were able to do it at the end as well.
Hello, and I'm Jose Solares. So I helped Michele out a little bit with starting on the version 2 of the code. We started with just knowing like what the general RCS value should be and basing our result off of that. But he developed the rest of it and added the equations to properly get it going. I contributed to editing the progress report. And I also drove the car in the video that you're gonna see and provided a dialogue for the explanation of how we set up the project and the demo and the testing area and as to how that works. So I've been studying the RCS collection techniques because I was not very familiar with RCS values or just radio frequencies in general coming into this project. So I've been researching more to get up to speed and catch up to where my team is at because they're a little more knowledgeable on this aspect. And then also started to plan a little roadmap as to how we're going to integrate machine learning into this project and what techniques would be best. Have a couple that we could use and seeing just how far we can really take this. As you know, I asked you a couple questions last week, and based off of that, I've been spending some time on that. And then also I'm on a Mac, so we were trying to see if we could get the Pluto working on a Mac. And thankfully we could, because now we would have to do a virtual machine or something else of that sort. But it's just it's just a rule change for the Pluto, and then that caused some issues with Windows, and we tried to take it back. So that's what Michele spent some time on. But now we got the method going for switching back and forth, and it's smooth. So yeah, that's what I've been working on for the project.
Great.
And then finally, for the next couple weeks, we're planning on finalizing the code for acquiring the RCS values. We have a lot of refinements to make about the gain, the frequencies we'll transmit at, and as well as making a standardized testing environment. We've come to learn that a lot of factors affected, like how far away we are from the object, the angle that we hit it at. So we want to try to make it so it's as simple as possible for collecting the first values. We also want to try to use some other objects to help in that. We're thinking to use a sphere for it, since it would reflect in all directions the same power. We want to start the machine learning before the next progress, as well as start the next phase of the hardware and start planning how we will make it more portable with the Raspberry Pi and battery.
Nice. So far you have been able to connect the Pluto, right, on each of your computers, and have you been able to get data or?
Yes, we have. We've collected the first set of data. It's not great so far because we have some refinements. Scaled down. At first, we were off by very large numbers. Now we're off by like a factor of 10, but it's still not great. So we got to get much closer to what we should be. And we anticipate, in the next week, 2 at most, we should have that down.
Okay. And where do you plan to do all the experiments? The scatterers.
We're planning to do it on the engineering center campus,
Okay.
either in a study room or in an empty classroom. We sometimes need a longer length to measure, so we need long tables, basically, so this way everything's level.
Right. Yeah, you need to be in a controlled environment, and I don't think that you have to start doing things, but if you are in a very small room, maybe the data you get are not very good because you might have many scattered data from around the room. Most of times it's good to be in an open space, either in a big room or outside. But yeah, you have to start getting data and see how things go. Yes.
We did it in the study space out, like, like that area where like the Panther Pit area type of thing, where there's a lot of space.
Yes.
We did it there, so there was a sufficient amount of space there, I believe so.
Okay.
It wasn't in like a closed classroom, it was pretty. That's
Yeah.
how we got closer to the reading than we did before, just for the
Okay.
flat one, obviously, because we haven't still because then for other objects, we would have to figure out more of like a dynamic thing. So, which by the way, I wanted to ask, is it based on like will we have to rely then on like pulse detection and like to see like Cause like, I don't really see how it's gonna work because we can't manually, it would defeat the purpose if we manually type the dimensions and manually type like the different formulas. That's why I'm saying, like, how would we go about it? So it could like be like, this is this shape and I'm gonna collect this RCS value because this is the formula. You get what I mean?
Right, you have to have some type of database. First, let's get the data. Let's make sure that you can identify distance and then the RCS from an object, and then you will do this classification. That's down the road. But yes, to do that, you need to have a database. So you need to have some type of identification. And I said there are data available in literature, and Michele asked me last time. I said that the RCS of a plate is known. There's an analytical solution, and you can find it. Or of a sphere is also known. And what you can do is you can have this analytical solution or from a paper, and you can compare with what you're getting from your Pluto device. And then you can have a database of different sizes of spheres, different sizes of plates, different objects. And you can start creating some type of algorithm that we were discussing last time, I think, for machine learning. But first, the first step is to make sure you can get data from the SDR and you can identify at least distance.
Okay.
And then once you have distance, you're going to identify, you see the RCS.
Mhm.
And then after the RCS, we're going with of a specific object, we're going to put different objects.
Okay.
And then you can maybe you also want to do some Doppler effect. You start moving things and you can say, okay, I have a car now, and then it moves, so you can identify the speed of the car. How the police does with the radar system. It's exactly the same thing. So you can do all these little things
Mhm.
for starters, and then you do more on the RCS aspect. But the low-hanging fruits are the ones that I described.
Okay. Well, is that it?
Any other question?
I think that's it for the presentation, but we have a couple of questions that we wanted to ask you. I think it's okay. So we have how can we get the Raspberry Pi on the battery? And then we have how can we get the sphere to use as a target? And then errors in ideal RCS code. Do we need a model?
What do you mean? The first question, if we buy for you? This is a question?
Yeah.
We'll have to see that. I have to talk to Dr. Georgakopoulos about that.
Okay.
And for the rest, the same. I mean, a sphere, again, we have to find the sphere. The easiest thing for a sphere, you can just get a foam-based sphere, and then you can put around an aluminum foil.
Okay.
You don't need to buy a metallic sphere. It's very expensive. It will not be smooth, but it will do the job. Same for a cylinder, and you can find this from different places. Errors in ideal RCS code.
So
The model, what do you mean here?
you want me to explain it? I just don't know what you mean by model, but you know you sent us the book and then you sent us a link to the MATLAB code for calculating like ideal RCS code. So we tried to run that on MATLAB and we were getting errors. And so I'm pretty sure Michele wanted to ask if we need a specific model he can
It
get.
seemed like it was running an STL model through for, I guess, using the,
I mean, I have to see the errors. If I don't see the errors,
sure, it was specifically with the creating the platform and the fact that we didn't have a .stl file, which I know is like a 3D model. Do we have, are you saying we should like model the objects that we're looking at and then run those models through code that would collect the RCS, or?
I need to see exactly what the error is. I
Oh,
cannot.
Share your screen. You can share your screen.
I need, yeah, to code and see what you get. I don't know if it is if
Yeah.
a library is missing or a package, or if it needs input data that you don't provide.
It should still be recording though.